Alright, so as you can see, we're going to continue to talk about simplifying radical expressions. We're actually going to step it up a notch to the harder stuff today. I'm going to try to teach it to you as best I can while not being there, especially with the first part where we're talking about fractions. It's really important that you understand what I'm talking about when we say how we change fractions, because that's really what the focus is with today. Just reminder from last time when we talked about simplifying radical expressions, we talked about breaking this down. The main method that we talked about, let's say I had something like the square root of 20, where I know that's not a perfect square. It's a little bit more than 4 because I know the square root of 16 is 4. But if I wanted to have an exact answer and I wanted to simplify this radical expression, remember what we did the last couple days? We started with the prime factorization of this, and we said, okay, well, 20 can break down to 2 and 10, and then 2 and 5. And so really the square root of 20 is the same thing as the square root of 2 times 5, because 2 times 2 times 5 is 20. And then what's nice is because we have square roots, remember square root is a number times itself twice gives me that number. And so what happens is really, in a roundabout way, what we're doing is we're breaking this apart and we're saying, okay, well, I have the square root of 2 times 2, and then I have that times the square root of 5. And the reason this helps me is because 2 times 2, well, that's 4, or it's 2 squared. Whichever way you look at it, if I have the square root of 2 squared, or I have the square root of 4 times the square root of 5, well, we know what the square root of 2 squared is. 2 squared is 4, and the square root of 4 is 2. And the reason that's true here is because if I have the square root and I have something squared, those two actually cancel each other out. The squared and the square root cancel each other out, and I'd be left with 2 root 5. Now, none of that is new today. That's what we've been working on so far. And we talked about having no perfect square factors under the radical and what it means to simplify radical expressions. Today, we're going to step it up on you a little bit. As you know, this is what we talked about. We said to make sure that the radical expression is in simplest form, we said there are two things that we really need to see. And the one that we've worked on the last couple of days is number one, no perfect square factors under the radical. So the example that I just gave you back here, there was a perfect square factor under the radical. If you look at the square root of 20, that's the square root of 4 times 5. And since 4 is a perfect square, there was a perfect square factor under the radical. So we had to simplify that down. That's the rule we've been working on, no perfect square factors under the radical. Here's more of the focus today, and we've touched on this a little bit, but it's going to get a little more heavy today. There are no fractions under the radical sign. So remember, I just don't have a fraction under the radical sign at all. And then there can be no radical sign in the denominator of the fraction. No radical sign in the denominator of the fraction. So remember what we said as far as what's okay and what's not okay. I can't have the square root of 3/4 or something like that. I would have to clean that up. I can't just leave it as the square root of a fraction. Okay, so that's no good. Can't have that. Okay, that's what it means by no fractions under the radical. The next says no radical sign in the denominator of the fraction. So what that means is I could have something like this, and in fact, that's what we talked about this becoming so far. If we have the square root of 3 over the square root of 4, really that's just the square root of 3 over 2. That's okay. This is fine. What we can't have is something like 3 over the square root of 2. That's not acceptable because now you have a radical sign in the denominator of the fraction. And that last part there is what we're really focusing on today. If we have a radical sign in the bottom of a fraction, how do we get rid of it? How do we adjust for this? Okay? To do this, it really helps us to look back at some things that we should already know. It says write 3 equivalent fractions to these fractions. And so, like for the first one, we have 2/3. And remember, there's infinitely many possibilities as far as what fractions are equivalent to 2/3. But if you start to think about it, okay, well, I have 2/3. That could be the same maybe as 4/6. Let's maybe say we double both of them. I could also multiply 2/3 both by 3. So 2 times 3, 3 times 3, and then I'd have 6/9. Okay, that works. Those are equivalent fractions. I could do them both times 100, and I could have 200 over 300. All of those are equivalent fractions. All of those still are worth 2/3. And remember, the reason behind that, what you learned way back in 3rd or 4th grade, is what you were doing is you're timesing these. Let's say that last example. I'm timesing the top and the bottom both by 100. I'm timesing the top and the bottom both by 100. And the reason that that works is when I have 100 on top and I have 100 on bottom, remember what this is actually worth. 100 over 100 is still just worth 1. So when we're doing this, we're still just taking 2/3 times 1. Now it's a different representation of 1, but it's still just multiplying it by 1. And we know if we multiply a number by 1, we're still back to what we had to begin with. And so that's why this works for fractions. The same would be true when we're looking at 1/5. Well, we could say 2/10. Sure, or we could say 3/15, or we could say 1,000 divided by 5,000. All of these are still equivalent to 1/5 because every time we were multiplying them by something that's really equivalent to 1. For the first one, we were multiplying them times 2 over 2. Well, that's worth 1. For the second one, we were multiplying times 3 over 3. Well, 3 divided by 3 is 1. And for the last one, we were actually multiplying them both by 1,000. But it doesn't matter because 1,000 divided by 1,000 is still equal to 1. That's critical to what we're going to think about today because remember, we're dealing with fractions almost exclusively today. So I need you to understand that. As long as you multiply the same on top and at bottom, you are not changing the value of the fraction. Okay, another big thing that we need to understand is just how square roots work and what happens here. So notice it says the square root of 9 times the square root of 9. Well, what's going on with the square root of 9 times the square root of 9? Well, let's think about that. What's the square root of 9? Well, the square root of 9 is 3. So if I have the square root of 9 times the square root of 9, I really have 3 times 3. And notice 3 times 3 gives me 9. And so the square root of 9 times the square root of 9, what basically ends up happening is those square roots cancel out. I have the square root of 9 times the square root of 9, which just ends up giving me 9. Let's look at another example. Square root of 3 over square root of 3. Well, we don't know the square root of 3 times the square root of 3 because we don't know what the square root of 3 is. But what I do know is what I just noticed up here. If I had the square root of 9 times the square root of 9, I got 9. If I take the square root of 3 times the square root of 3, I think we should know what we should get. Remember, the shortcut for writing this would be the square root of 3 squared. Well, recall, we just talked about this, and we talked about it earlier in the week, but remember, if I have a square root and I have something being squared, those are inverse operations of each other and they cancel out. That same thing is true here. If I have the square root of 3, it doesn't matter what it is. If I take the square root of 3 times the square root of 3, by definition, I have to get back to 3. And so notice what happens. The square root of 3 times the square root of 3 just equals 3. So in general, I think we can start to notice something. We could say, well, if I have the square root of x times the square root of x, well, that's the square root of x squared. And so if I have the square root of whatever this is times the square root of that same thing, remember, by definition, the square root of x is the number that when I take it times itself, I get x. And so we're back to this answer of x. Once again, those square roots canceled each other out. And so this starts to lead us to a pretty important notion that we've already kind of talked about, the square root of 4 squared. Well, you can think about this two ways. Yeah, we know what 4 squared is. 4 squared is 16. So what's the square root of 16? Well, hey, the square root of 16 is 4. And so remember, when I have the square root and I have something squared, those are going to cancel out. I'm going to just be left with whatever our base was. So on that last example, you see the square root of x squared. Well, x squared, then take the square root of it, you're back to having x. They cancel each other out. And so that tells us everything that we need to know for today's work. If we're going to simplify these radical expressions, if we're going to make sure there's no fraction under the radical sign, and there's no radical sign in the denominator of the fraction, there's two things we need to know. First thing is, we can do whatever we want to fractions as long as we multiply them or divide them both on top and bottom by the same thing. You times them both by 5 on top and bottom. You divide both by 10 on top and bottom. If you do the same thing on top and bottom, it does not change the value of the fraction. That's critical. The second thing we need to understand is, let's say I want to get rid of the square root of 3. If I want to get rid of that radical sign, if I'm looking at this example and I'm saying, man, I want to get rid of those square roots. Well, if I had the square root of 3, and I wanted to get rid of the square root, I don't want to change anything else, but I just want to get rid of the square root. The simplest way, without knowing what the square root is if I have the square root of 3, to get rid of that square root, I'm just going to times it by the square root of 3. If I times it by the square root of 3, notice the square root of 3 times the square root of 3, remember that's the square root of 3 squared, and those radicals cancel out, and I'm left with 3. So at any point, if I'm trying to get rid of radicals in the denominator, that's going to be the trick. Let's take a look at some examples. The first one says the square root of 9/5. The square root of 9/5. Well, so we're still back to our basic steps that we've talked about. As we do this, we want to break this up. We want to take the square root of the top over the square root of the bottom. Now the nice part about this is we know the top, the square root of 9 over the square root of 5. We know the square root of 9 is 3. But here's where we now have our issue. We have 3 divided by the square root of 5. 3 over the square root of 5. Now recall what we said earlier. We can't have this. We can have no radical sign in the denominator of a fraction. This is not in simplest form. So we've got to do something about it. The problem that we have is that there's a square root of 5 on bottom. We've got to get rid of that square root. We've got to get rid of that radical. So what I want to recall is what I just talked about. If we want to get rid of a square root, the simplest way to get rid of a square root is to multiply by the exact same square root. If I have a square root of 3 and I want to get rid of that radical, I'm going to multiply by a square root of 3 because the square root of 3 times the square root of 3 equals 3. In this case, we want to get rid of a square root of 5. We want to get rid of that radical. So the simplest way to do this is to multiply it by the square root of 5. We know that those radicals are going to end up canceling each other out because we have the square root of 5 times the square root of 5. We know what that's going to give us on bottom. Here's the key. We said to do it on bottom, we have to do it on top. To multiply by 1, we have to multiply them on both. And so if you're going to do this, if you're going to simplify radical expressions by multiplying by a square root, I have to do the same thing on top that I do on bottom. So I have 3 over the square root of 5 times the square root of 5 over the square root of 5. Recall, the square root of 5 over the square root of 5, that's the same number divided by itself. That's still worth 1, so this is still going to work. But watch what happens. 3 times the square root of 5. Can't do anything with that. I don't see anything that I can clean up. I don't see anything I can cancel. That's just 3 times the square root of 5. But here's what we get, what we want. We have the square root of 5 squared. We have the square root of 5 times the square root of 5. And we recall that those radicals cancel each other out because the square root of 5 times the square root of 5 is just 5. I know it still looks messy, but 3 root 5 over 5 is now simplified. You have no perfect square factors under the radical, you have no fractions under the radical sign, and you have no radical sign in the denominator of the fraction. Now, inevitably, somebody typically asks, well, can't we simplify? We have 3 root 5 over 5. Well, notice in our final answer, 3 root 5 over 5. You can't cross cancel. You cannot say, well, 5 divided by 5 is 1 and 5 divided by 5 is 1, because this right here is not 5. That's the square root of 5. Okay, and so since one's a square root and one's the regular 5, they are not the same. We cannot divide them both equally. Now that's different if I had something like 3 root 5 over root 5. Now they are the same number. What's the square root of 5 divided by the square root of 5? Well, it's 1. This could simplify down and be 3. But when one's under a radical and one's not, this is as good as it gets. Let's look at a couple more examples. This one says square root of 6 over 32. So lots of stuff to do with this problem here. Now, one nice thing that we'll talk about in class, but you can simplify before or after. If they're both under the radical, one thing that we can do is we can try simplifying before. So one method that we might do on this is say, okay, 6 over 32, I can divide them both by 2. Well, that's just 3 over 16. I divided 6 by 2, I divided 32 by 2, I get 3 over 16. Well, that's the square root of 3 over the square root of 16. And guess what? Square root of 16 is 4, and I'm left with square root of 3 over 4. And I've got my final answer. And I didn't have to do any of this complicated stuff. However, some kids typically don't start that way. They forget, oh, I could have reduced, and they just start going. So they have the square root of 6 over the square root of 32. Now it gets a little messier this way, but we can still get away with it, and we can still get everything that we need to get done. Square root of 6 cannot be simplified because it's just 2 times 3, but remember, 32 is one that we've simplified. We can take the prime factorization, and we can say, okay, well, what all do I have here? And I work this out, and I'm looking for pairs that I can bring out. And so notice I have 2 pairs of 2, which is 2 times 2, which is 4. So I could actually call this the square root of 6 over 4 root 2. That's just from last time. Square root of 32 is the same thing as 4 root 2. We've done this before. That's the same as what we've been doing the last couple days. Now here's the problem. We can't stop here. We have a square root of 2 on the bottom of our fraction. Can't have that. Well, how did we take care of that? If we wanted to get rid of the square root of 5 on bottom, what did we multiply top and bottom both by? We multiplied them both by the square root of 5. So I'm going to do the same thing here. I'm going to multiply this by the square root of 2, but if I do it on bottom, I have to do it on top. Notice all the stuff that happens here. Lots of action that's going to go on. I have the square root of 6 times the square root of 2. Square root of 6 times the square root of 2. Remember, under the radicals, we can multiply. Square root of 6 times the square root of 2 is the square root of 12. Okay? On bottom, we have the square root of 2 times the square root of 2, which we said is 2. But so now this becomes 2, and then I also have 4. 4 times 2 gives me 8. So I have root 12 over 8. With me so far? Take a deep breath and then think, I'm done. Well, no, not exactly, because now we have the square root of 12. That's something we can simplify. Remember, we've looked at this before. We can do the prime factorization. We can simplify this down, and guess what? It ends up being 2 root 3. I have a pair of 2's, so 1 2 comes out, so I have 2 root 3 over 8. And now last thing that I want you to notice, we just talked about this. If they are both under the radical, we can simplify like normal. Well, the same thing is true if they're both outside of the radical. As you look at this one, we have 2 and 8 on 2 on bottom, 2 on top, 8 on bottom. They are outside the radicals. We can cross cancel these. We can reduce these. 2 divided by 2 gives me 1, and 8 divided by 2 gives me 4, which gives us our final answer. 1 times root 3, well, that's just root 3, and then root 3 over 4. Now notice, we got the same answer either way. One required quite a bit more work than the other. So I do want you to notice that you can reduce under the radical if possible. So if you see a fraction under the radical that can be reduced, do it. If not, you can still go through all these steps where you simplify doing the things that we've already talked about to get the same answer. So last example, 3 root 15. 3 root 15 over root 27. 3 root 15 over root 27. 2 ways to do it. The long way, the short way, it's up to you. Let's go with the long way first as we look at this. Let's go the short way. I don't want to get too messy on this video. So what I want you to notice is we have 3 outside the radical, but then we have root 15 over root 27. And if we have root 15 over root 27, that's the same thing as the square root of 15 over 27. This is the radical, or the square root of all of this. We have the square root of 15 over 27. And so we should notice that we can do some reducing here. Divide them both by 3, and this becomes 5 ninths if I divide them both by 3. So what I really have now is I have 3 root 5 over root 9, just because of the reducing that we did. And when we do that, that works out really well for us, because now we see 3 root 5. Well, I can't simplify anything there, but on the bottom we have root 9. So this becomes 3 root 5 over 3. Square root of 9 is 3. Now you might think that you're done, but remember the last thing that we just talked about. If I have 3 root 5 over 3, both of these 3's are outside the radical. So I have a 3 on top, a 3 on bottom. I can cross cancel those. They both become 1. I have 1 times root 5 over 1, which really gives us the final answer of the square root of 5. Those are the examples that you have in your notes. I would give you just one more example to really try to get this idea down in your brains. Let's say we have something like, let's just say we have 3 over root 5. As simple as it can be, maybe. But I have 3 over root 5. The bottom line is I can't have this square root under the fraction. I can't have a square root on the bottom. So we said to get rid of it, we're going to multiply it by itself. We're going to multiply it by a square root of 5, because we know what happens when we take the square root of 5 times the square root of 5. The only other thing you got to remember is whatever you do on bottom, you got to do on top. So notice I have 3 times root 5, so that's what gives me what I have for a numerator. And then I have root 5 times root 5, which again, that's the square root of 5 squared. So not even knowing what the square root of 5 is, I know if I square it, I'm going to get 5. So you end up with 3 root 5 over 5. And remember, we can't do any simplifying or cross canceling because 1's under the radical and 1 is not. Just a little bonus example to really try to help you see how this is going to work. A couple things to point out in the notes, like we talked about. 3 pages that really help you. The first page is something that we've already talked about as far as what we're looking for when we simplify square roots. The rules as far as if it's in simplest form or not. The second was that whole idea that we talked about, where to mess with fractions, we have to multiply and divide by the same thing. Multiply the top and bottom by the same. Divide the top and bottom by the same. That's the only way these fractions stay equivalent. And then lastly, that idea of, well, how do I get rid of a square root? The main idea is if I have a square root of some non-perfect square, take it times itself. Square it. And if I do that, that gets rid of those radicals, and I'm left with just a regular integer like I wanted. And so that's how we did these 3 problems. Again, we're still doing the same steps we talked about the square root of top over square root of bottom. Still going to do some cleanup like normal with the prime factorization, but then you see how we can actually get rid of those square roots on bottom if we have to. And that last example really goes over that. Should be enough to get you through today and tomorrow, and then we'll talk about it a little bit as we get into class tomorrow. Thanks.